Okay, today we are going to learn the Octave or the MATLAB programming. Okay, so Octave and MATLAB actually are two different software. Okay, but they use the same language, same programming language. This language is very powerful in matrix manipulation. That means we can create matrix easily. It process matrix easily. Just like you have the you have learned the Python, the pandas, right? Okay, uh, not sorry, NumPy. I mean NumPy. Uh, okay, it's a tools for you to process matrix, right? But for Octave and MATLAB, okay, the matrix manipulation is just something built in. You do not need to import anything. Okay, it's already uh, something. It's a language that deal with matrix by default already. Okay, so it also can let us plot functions easily. Okay, later I will show you how to plot, do plotting, including 2D and 3D one. Okay, uh, we also can implement algorithms easily in this language. That means before we go to the real production, where programs are written in Java or C++, we can use Octave or MATLAB to implement our algorithm first to prove the concept, and then only we go to the real production. Okay, Octave and MATLAB, since they are two different software, okay, they use the same language but with some differences, some small differences. So you can check this website, okay, to learn what's the difference between these two. In fact, they are very small. Okay, some minor differences. Okay, uh, most of the time we can assume that the program wrote in Octave can run in MATLAB as well. Okay, so what's the difference between Octave and MATLAB? The main difference here is Octave is a free software. Free in terms of freedom. Okay, it means you can download it, you can use it, you can run it, you can modify it if you want. Okay, in free. Okay, you can download the software from this website. Okay, for MATLAB, it's a proprietary software. Means you have to pay for it. You can just use it as it. That means you are not allowed to change anything. You have to pay for every updates and also the add-ons. Okay, you can check in the MATLAB website if I'm not mistaken, to get a copy of MATLAB in the while this is done is free. To get a copy of MATLAB in Malaysia for academic purpose, they charge USD 275, I think, if I'm not mistaken, for academic purpose, 275 per year. And this is just a basic only. I mean, if you want some more add-ons, you have to pay for the additional cost. Okay, um, so Octave, okay, maybe you just focus on Octave, okay, but it applies to MATLAB as well. Okay, for Octave, you can run your program in two modes. One is so-called the interactive mode, the other one is a scripting mode. This just like the Python. If you have learned Python, okay, you can write your full program, okay, and run the program as one complete script, or you can use the IPython, okay, to run one command by command. Okay, so this is so-called the interactive mode, and you can run the scripting mode as well in Python, in Octave, I mean. Okay, and for Octave, you are always deal with a program which is case sensitive. That means if you create a variable called ABC, okay, this is different from ABC, which is capital letter. If you have a command print, okay, this is always different from words called print, which is capital letter. Okay, command case sensitive. So okay, let me show you the maybe let me start with showing you the interface of the Octave. Yeah, this is the Octave installed in my computer. Yeah, it's a bit old, but you can find the latest version uh, in the website I showed you just now. So here, okay, you can see this is a sort of a file browser. You can look for your files here, okay, and all the file you save is you can save it with the extension .m. Okay, um, this is a place where you issue your commands, okay, to Octave, okay, and you have an editor here as well to edit, to write a complete program. Okay, to write a complete program and then run. Okay, you can use the editor here, or actually you can use your own IDE. Means if you prefer some other text editor, you can use other text editor as well to write a program. As long as it is a text editor, it works. Okay, you include the notepad in your Windows. Okay, and then after you write the program, you can run here. Okay, now let me introduce you a bit about how to run some simple commands. For example, if I want to have 2 plus 3, okay, so you see you get answer 5. Okay, or you want some power, let's say multiplication, you get, okay, the multiplication of 3 times 9. Okay, for power, let's say 3 power 2, 9, right? So this is the some basic arithmetic operations you can find in Octave. Okay, so yes, we also can process so-called the complex number. Okay, I is a notation for complex number, right? We also can do this in the Octave. Okay, this is the power. Okay, so we also have some built-in function in Octave. For example, sine, cos, tangent, square root, absolute number value, exponent, log, okay, and round, and so on. Okay, okay. Take note here, two things. First, for sine, cos, and tangent, all the value that become their parameter are in radian. Okay, not degree. Okay, we are not talking about degree in our course. Actually, for all the variables we have in this course, everything is in radian. Okay, not in degree. Okay, so sine, cos, tangent are all the what called radians. Okay, for example, cos 3.14. Okay, if you remember, the cos function is something like this. Okay, this is pi over 2, this is pi, right? So pi, this is pi, cos pi should be equal to -1, right? So let's see, cos cos 3.14 pi, okay, is equal to -1, right? So this is the first thing, okay, in radian. And secondly, the log here, this one doesn't mean the log base 10. No, this is actually the ln. Okay, the natural log. The log base 10 is this one. Okay, so this one you can expect this one to get 1. You see this one 3.74, this is the e, right? The natural number. This should be 1 as well. Let's show you. Okay, log 3. Yeah, is it this one? No, 78. Okay, 783 1, right? Log okay, maybe I try the 10 first. 10 is 1 also. If I use the log 10, you see this is natural logarithm, right? So you won't get 1 because this is the ln. Actually, the log, okay, we have here, actually is the ln. Okay, as I mentioned, it's a ln. Okay, so we can find other as well. This is exponent. Yeah, one more thing is about the some constants here. Pi and e are just two. We don't use these two as variable. These are constant defined in the Octave. They will give you the natural number e and also the pi. Okay, so you see pi, you get this number. E, you get the natural number. Okay. Okay, we can create variables, okay, including vectors and matrix easily in Octave. Okay, so let me demo. Okay, so let's say we want to create a variable called a. okay, A equal to wait, okay, A equal to 3. Let's say A equal to 3. Okay, so you see we have created a variable A. So if you want to know what's the A, you can just type A. Okay, it shows you A equal to 3, or you can use a command called display. Okay, you display the value of A, 3. Okay, so this is a variable. Okay, one single variable. If we want to create a row vector, we can just write, let's say B. Okay, B is equal to 2, oh wait, B equal to 2, 3, 4. Okay, I have a B, row vector B. Okay, 2, 3, and 4. You see, this is a row vector. I can just split the number 2 and 3 and 4 with space, or if I want, maybe I try the other one. I call C equal to 2, 3, 4. Okay, the last one no need comma. Okay, you see, I get the same thing. Display B. Okay, I get 2, 3, 4. Display C. I get the same thing, right? So with the comma or without, it's the same as long as you split them with the space. Okay, this for row. If we want to create a vector, what I call it, the matrix. Okay, let's say I call it a D. D equal to a matrix. Okay, let's say we want to create 3 by 3 matrix. This is what I do: 1, 2, 3, the first row, and then the second row, semicolon, 4, 5, 6, and then the third, 7, 8, 9. Okay, so this is the matrix, a 3 by 3 matrix. First row, second row, and third row. Okay, 1, 2, 3, 4, 5, 6, and 7, 8, 9 respectively. So of course you can create a larger matrix if you want. Okay, but let's say I want to retrieve, okay, the element in the matrix. Okay, if I want to get the whole matrix, I can just type D, because the matrix is called D, right? If I want to get, or I can just type display D or same. Okay, if I would just want to get one of the element in the matrix, let's say I want to get the row 2 column 3. Row 2 column 3, what I do is a D 2, 3, row 2 column 3. Okay, you get 6. Okay, this is a row 2 column 3, right? Row 2 column 3. Okay, so to get, okay, to change, let's say you want to change the value of row 2 column 3, you also can do this. Row 2, D23, row 2 column 3, we assign it to a new number. Let's say 0. You see, we have the new value for D already, right? The row 2 column 3, which was 6, now becomes 0. Okay, now let's say I want to retrieve part of the matrix. Okay, I want to retrieve the row 2 only. Okay, what I do is D. Okay, I use this. Okay, row 2 and everything in the row 2. Okay, the colon. Okay, colon here, the first number 2 is means row 2, right? The colon on the second, as a second parameter, means everything. Okay, I use the double colon here, means everything. If I want to get the first column only means I can type D everything. Okay, for the row, 1 for the column, I get the 147. Row 1 to 3. Okay, column 1. Okay, so if I do this, guess what I get? I will get D 2, 3. Okay, 2 column 3, and then 1, 2. Guess what I will get? This one. Okay, so actually the answer is row 2 to 3. Okay, D. Okay, you see 2 column 3 means column row 2. Okay, row 2 to row 3. Okay, row 2 to row 3, and for column is column 1 to column 2. You refer to here, you see this is a D. Row 2 3 means row 2 to 3, okay, row 2 to row 3, 1, 2, the column 1 and column 2, right? Column 1 and column 2, that means you get the 4, 5, and 7, 8. Okay, you get this one. Okay, you get 4, 5, and 7, 8. So this is so-called the column notation in the Octave. Okay, so you can refer to this example here. Okay, and the format. Okay, I describe here. So yeah, if I want to create a array, okay, with continuous number, I can do so. This one will give us an array start from 1 and at 5, okay, all the integers from 1 to 5. So let me show you. You see, just now we have D, now I call it as F. Okay, we cannot use E because E has a reserve for the natural number. F is equal to, let's say I type 10 to 20. This one will give us a array from 10 to 20. Okay, all the integers from 10 to 20. I change it to 12 to 15 also can, right? So but let's say if I want from 12 to 15, okay, but the interval is not 1. Now you see the interval is 1, 12 to 13, 1, 13 to 14, distance is 1, right? If I want the distance is something else, let's say for example distance is 0.5, what I do is this. Instead of 12, 5, 12, 15, okay, I put a 0.5 in the middle. Okay, you see, this one will give us from 12 to 15 with the interval 0.5, 12, 12.5, 13, 13.5, 14, 14.5, and 15. Okay, so this one, and then the multi-dimensional matrix. Okay, so you see, just now we have a D, right? D is this is a matrix. Okay, this is a matrix, 3 by 3 matrix. Okay, but this is a matrix with 2 dimensionally. If let's say we want to have a 3-dimensional matrix, what I mean is this one. It's just 1, 2, 3, 4, 5, 0. Okay, this is the first page. Okay, you can consider the first page of the matrix, and then the second page you have something else. Let's say this is 11, 12, 13, and so on. Okay, until this is 19, this is 16. Okay, 2-dimensional, 3-dimensional one. Okay, you can do so. Start with this one, the D. Okay, and let me create a copy first. Just have G. Okay, G. Let's say I call G as D. I don't want to overwrite the D. Okay, okay. I create the G as the D. Okay, I mean I copy the D to G first. Okay, this is a G. Now we already have the first page of G. Now we extend the G. G in the bracket, everything. Okay, the dot means everything, right? And then the second page. Okay, the second page of the G. Okay, just now the 1, 2, 3, 4, 5, 0 is the first page, right? Now the second page of G is let's say I create 11, 12, 13, 14, 15, 16, okay, and then 17, 18, 19. Okay, you see, we have a G. Okay, we have G with first page. Okay, the previous one, and the second page is this. Okay, these are the number we have on the second page. So this is to create a multi-dimensional matrix. Okay, there are some operators or functions related to matrix. Okay, for example, this one is a function for us to find the inverse of a matrix. This one is a function for us to find the determinant of a matrix. Okay, just one line you can find the inverse or the determinant. Okay, this one just a prime. In the prime here means we find the transpose of a matrix S. Okay, Of course, for matrix, if the dimension allowed, we can do the addition, subtraction, okay, and assign the value, the result of subtraction to a new variable. Okay, we can perform the multiplication. Okay, but of course there are two types of multiplication. This is one is a so-called the traditional matrix multiplication, but this is a array multiplication, element wise or element wise multiplication. I will show later. Okay, maybe just okay, come to the demonstration. Okay, now let's say we have a D just now, right? Wait, D is this is matrix D. Okay, now you see, let's say I call this as a H. H is the inverse of D. Okay, yeah, we find the H, which is the inverse of the D. Okay, if you want to find the determinant of D, determinant, this is negative 36. How about the determinant of the H? It's a different number, right? Different value. Okay, and what else? Okay, transpose. D is this one. Transpose of D. With a prime here, we find a transpose. You see, the column become the row become the column, right? So this is transpose. Okay, let's say I call the D transpose. Okay, D K. I call K as a D transpose. Okay, so we have K and D. Now we want to find what is D plus K. You can just use a add, okay, the plus sign to do the addition. Okay, and then what else? Just now we have okay, yeah, multiplication. Yes, multiplication. You see, this one is okay, D times K. Okay, D times K. This is what we get. This is what we, okay, this is the matrix multiplication, or the multiplication that we use normally. Okay, but for the other one, okay, which I call it as a element wise multiplication, I use a dot. Okay, I have a dot here, dot K. D dot K, we get a element wise multiplication. What I mean is this one. Okay, or maybe okay, let me start over with the other example. Let's say I call it as H. Okay, let's make it easy. H is equal to 1, 2, 3, 4. Okay, small one, easy to explain. K is equal to 3, 5, 6, 0. Let's say. Wait. Oh, typo here. Wait. Okay, so this is H, this is K. Now, okay, so the matrix multiplication is a multiplication we use normally in matrix. So this one will give us, okay, 1, 3 for the first, okay, first result here will give us 1, 3, 3, 1 times 3, 3, 2 times 6 is 12. Okay, we get 15. Okay, 1, 5, we get 5. 3, 0, we get 0. We get 5 here. Okay, for the row 2, row 1, column 2. Okay, so for this one, 3, 3, we get 9. 4, 6, we get 24. The result is 33. Okay, and then the last one is a 3, 5, we get 15. 5, 0, we get 0. Okay, then we get 15 as a result. So you see, if I do H multiply with K, we get this, right? Correct or not? So this is the matrix multiplication that we learn in mathematics, okay, normally. But for the other one, the element wise multiplication is this one: 1 2 3 4 3 5 6 0. Okay, so if you use this dot multiplication, the dot version, what you do is you multiply element to element. 1 to 3 only, okay, you get 3. Okay, 2 to 5 only, you get 10. Okay, 3 to 6, you get 18. 4 0, you get 0. So this is the with the dot version. Okay, dot multiply, this is what you get: 3 10 18 0. Okay, so this is the element wise multiplication with the dot one. Okay, we need this a lot in our applications. Okay, we need this a lot in our course. Okay, so this one, the divide actually means the multiply with the inverse of the y. Okay, so you see, if I have this one, h is this. Okay, h divided by h itself. Okay, wait, h divided by h itself. Okay, divide shouldn't be something that we can see in the matrix, mathematically speaking, but this one just means that we multiply with the inverse of it, so we get a identity matrix. Okay, so this is the one. Okay, and the version with the dot, the version with the dot here means we divide element wise. Okay, element wise division, just like this one. This is element wise multiplication, right, with the dot. Okay, the one with the dot is element wise division, means, okay, this is, okay, again, this is k. Okay, no, maybe I want to use a h. Okay, h, this is the one. H element wise division, h, guess what you get? You get all 1, right? Because you divide 1 to 1, 2 to 2, 3 to 3, 4 to 4. Okay, so why I do not want to use k just now? Because you see, if I use k, I will get something not really correct, because it doesn't process the 0 divided by 0 correctly. Okay, so you just give a 1 here. Okay, which is not something correct. We still have some more matrix related function. Okay, for example, okay, okay, we can create a zero matrix. I mean a matrix with all 0. Okay, with this function. Let me show you zeros. Okay, with the s. Okay, if I type 2 3, that means I will have a 2 row 3 columns matrix, but all the elements are 0. And then I have ones. Okay, means all the matrix with all value as ones. Okay, let's 2 3 again. You see, all are ones. Okay, if I want a random matrix, means all the value in the matrix are random. Okay, same, rands 2 3, 2 row 3 columns, all the values are random. Okay, okay, so this is the one. And then, okay, guess what is the I here? I4. Okay, actually I means I. Okay, means we want to find the, we want to get the identity matrix with certain dimension. So EYE 4 will give us a 4-dimensional, I mean not 4-dimensional, 4 row and 4 columns identity matrix. Okay, and then for size, it's a function to retrieve the dimension of the matrix. Okay, for example, let's say I have D just now, this is D, right? 3 rows 3 columns. I find the size of D, you'll get 3 by 3, 3 rows 3 columns. Okay, so here are some examples, some exercises. Okay, you can try and then let me know if you have any issue in the coming lecture. Okay, it is easy to run a single command in Octave. Okay, just write the command and run, right, in the terminal. But sometimes for serious works, okay, it's more convenient to put all the commands, or to put all the lines we want to run in a single file, okay, or a set of files, okay, in order to run them together. Okay, most of the time for serious work we need to do so, right? So what we need to do is only put all the commands we want, okay. For example, these are the steps we want to do, these are commands, okay. We just compile all the commands into a single file, save it as a single file. Of course, when we put everything in a file, okay, when we call this a complete program or script, we need to write some command, okay, for the programs, okay. This is the symbol for us to write command in Octave, okay. Everything after this symbol will be treated as a command, so Octave won't process it. So you can create a command, okay, at the end of the line also, okay, or the single line with all commands, okay. So this is the, okay. Let me show you. Okay, so you see this is where we run the program, and this is the editor. Editor is a part that we can edit our program as a single file. Of course, you don't need to use this editor. If you don't like it, you can use your own editor. As long as it's a text editor, you can use it. Okay, your IDE, your text editor, you can use it to type the Octave program. So let me copy the program to here. Okay, this is the program we have. Okay, here, this one, I just copy it to here, and then you see we can save it. Okay, where to save it is very important. Okay, you see I save it in this directory. Okay, so I save it, let's say I call this program as a find diff. Okay, of course we need the extension .m. Okay, .m is the default extension for MATLAB and Octave programs. So I save it. Okay, after I save it, you see this is a current directory. Our current directory is here. Okay, I can come back to here, okay, to run the program. The name of the program is find diff just now, right? Find diff. Okay, and then I run, I enter, I run, I get the output of the program. Okay, the output is the difference. Okay, which is, okay, this is the output. Okay, so this is what I get. I can run it multiple times. Okay, just like all the programs we have. So this one is the one. Okay, okay, one thing is very important is you need to, as I mentioned just now, you need to make sure that your program is saved in the working directory in order for it to run. So to know where's your working directory, you can type the command pwd, enter. Okay, you find that this is your current directory, your working directory. Okay, you have to make sure that your program is saved in here as well. Otherwise, you have to use the cd command, okay, or you can do it here, okay, to change to the current directory. Okay, you can use the command you have here to okay, to change to current directory. Okay, yeah, I've discussed everything here. Let me see. Okay. Okay, now we are going to talk about output or output formatting. So actually there are three ways to display output in Octave. Let me show you. Okay, first, okay, maybe start with a very familiar example. Let's say I write k equal to 3 plus 5. Okay, plus 5. Okay, and then you see we get k equal to 8. Okay, you see we get the output directly once we type a command, right? But if I have k equal to, okay, same thing, but I add a semicolon here, I won't get any display. but in fact the 8 is already stored in the K. Let me try. Okay, I try to change the number and for you to see 7. 3 plus 7. Okay, I wouldn't see any output, right? But if you type the K, you see you already store 10 in the K, right? So the first way of getting an output is type the command, okay, without the semicolon, okay, or you can just type the name of the variable, you get the output. Okay, this is the first way. Okay, the second way is to use the display function that we already seen just now. Okay, you see I type the display K, I get 10. Okay, the difference between the previous one and this one is you use the display keyword, okay, or display function, you will get the content of the variable only. But if you use the K alone like this, you get the name of the variable as well as the content of the value is stored. Okay, so this is the second way. The third one, which is a bit more lengthy maybe, but it's the most powerful one, using the fprintf function. Okay, but before we go to fprintf function, I want to introduce you something first. Okay, just now we have seen that, okay, we can use a variable like K to store a number, right? A real number or integer, right? But now you see I can use variable also, okay, to store string. For example, my number is, okay, I store the m, okay, I store my number is, okay, this string as m. Okay, so if I type the display m, you see I get a string. Okay, but we also can use the fprintf function to print the m. Okay, so you see this is the content listed. The only difference is, okay, display here, the display function here, after it runs, it ends, it go to the second line. But using the fprintf function, it prints the output of m. My number is, it won't go to the second line, it will just stop here and then followed by the command input, okay, input of the terminal, right? So this is the different. But the thing that make the fprintf powerful is we can do a lot of formatting on the fprintf. Okay, if you have learned C++ or Java, you should be quite familiar with this one. For example, I type the, okay, fprintf. Okay, I can type anything. Okay, this is a string I want to print, let's say. Okay, 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 of course you know this is something that you get. Okay, you get this one. Okay, but to do formatting, okay, I can use a /n here. Okay, a /n means that we go to a new line. Okay, I will give you one more demo. I think you can see easily. This is a string. I put a /n here, means after this is my string. This is a string. After this part, okay, after this one, after this is a string. Okay, I will go to the second line, and then in the second line I will print. I want to print. You see, so the /n means next line, a new line. Okay, and also can change the n to t. Okay, a t means a tab. Okay, you can see the effect, right? So beside this, okay, with the fprintf, okay, maybe I give you more. The result is, okay, I add a %d here. %d means I want to insert a integer, an integer. Okay, what's integer? K. What's K? K is 10 just now. K is 10, right? The result is percent %D means that I will put the K to this position. Okay. The result is 10. Percent D is replaced by the 10. Okay. And okay, of course this is not something nice. We can add a slash n at the back so that it prints in a single line. Okay. To change, let's say if you want to have not replace this one, okay, as a string also can. Instead of using a D, I use a S. Okay, S, and then I can change it to M. M, where M is this one. The M is my number is, right? I can. The result is my number is, okay, where because the M is my number is, okay. Of course, I can make the format to be a bit more complicated. Percent %S, percent %D. Okay, I have two variables here. Percent %S for M. The second one, the percent %D for K. Then this is what you get. My number is 10. Why? Because the first variable is M. M will replace the S. And what is M? M is my number is. Okay, my number is, right? This one here. Okay, and the K is 10. 10, the K will replace the second one, the percent %D. Okay, then percent %D will be the 10. Now come to the decision making in Octave. Okay, if you have learned some other languages like Python, you know we can make decision using the if, elif, or else. Okay, se. Okay, in Python, right? So we have the condition here, okay, and then else something, right? So this is what you see in the Python, but for Octave, okay, the keywords you use is a bit different. Okay, you use if also, you need to put the condition in the bracket, okay, and then for ELIF, we use the else if complete one, okay, and else. Okay, so this is the difference. Okay, the first difference, and then the second one is in Python. Okay, you know the indent is very important. How many space you leave in the front one? The front is very important, right? For Octave, it's not that important. Okay, at least if you don't have the space, your program still can be compiled, but it's not easy for reading only. But you need an if keyword to end the if statement. Okay, this is we consider whole complete if statement. You need an if to terminate it. Okay, and then you do not need the colon. Okay, at the back here. Okay, to indicate this is the end of the one line. Okay, with the condition. Okay, you don't need this. Okay, so let's look at example. Okay, so you see here, this is one example. You have x equal to 5. Okay, and then you have the if statement. Okay, you check whether x is greater than 1 or not. If this is true, then you print this one. If it is false, okay, means go to else, you print this one. So after the if and else, you have the and if statement here to end the complete if statement. Okay, so this one is a simple example. We can also make the example more complicated with nested if. For example, this one. Okay, let's say we assign both x and y to 5. Both x and y are 5. So you check in the first iteration, not iteration, I mean the outer if. Okay, the if here, we check whether s is greater than 1 or not. Okay, if s is greater than 1, we go to this inner if, the nested one. Okay, if this is only if this is true. Okay, of course this is true because s is 5, right? S is 5, you go to here. Okay, we check all these things. Okay, if not, if this is false, then you go to the S here, you execute these two. But we know in this example, these two lines will not be executed because the S is 5, which is true here. Okay, this is true, then it will execute this part. But once it executes this part, the first block, okay, it will check, okay, whether y is greater than 1 or not. Y is equal to 5. So the inner if this is true, so it will execute this line. Okay. If this one is false, if this one is false, then it will go to S to execute this one. Okay, but since this is true, this one will not be executed. This one too will not be executed as well. This is the only output you can see, okay, in the program. Okay, now is a condition in programming, or something we call as loop. Okay, condition or loop is a structure that allows us to repeat a part of programs until certain conditions is fulfilled. Okay, so we also call this a control structure. Okay, so there are two types of loops in the Octave. One is a for loop, the other one is a while loop. The one should be small letter W. Okay, so and also as like other programs, a loop can be nested in another loop. Okay, so let's start with the for loop. Okay, the for loop has this syntax. Okay, start with the for keyword, and then okay, this is a condition. Okay, we assign the index to a certain value. Okay, with this assignment, we can have a set of statements in the body here. Okay, this is the one that we will repeat. This part is a statement that we will repeat until this condition is not fulfilled anymore. Okay, and we also need to terminate the for loop with the end keyword. Okay, here the condition of repetition, there are three types of condition normally we use. Okay, so the first type is in this form. Okay, we have a initial value of a variable until the end. What I mean here for this one, the value, okay, you can put it in this form. Okay, so that the index here will take these values, okay, from the initial to the end. Okay, and then we repeat the loop until the index reach the end value. Okay, the second form is we can use this one. Okay, instead of letting the index grow from initial to end 1, 2, 3 and increase until the end, we can set the step size. Okay, and then the third one is we have an array of value. Okay, with the array of value, the index will take the value in the array one by one until the end. Okay, let me explain with example. Okay, this one is the third one. Okay, the third one. Okay, the third one. Okay, this one. Okay, we have an array. A is an array of 2, 4, 6, 8. Then I use a for loop. Okay, for I equal to A. I equal to A means I equal to this loop. Oh, sorry, I equal to this array. Okay, and then I will be 2 in the first round, 4 at the second round, 6 at the third round, and 8 at the last round. Okay, so display here in the body here you have display means that you have this output 2, 4, 6, 8. Okay, so this one, okay, is the first one. I mean this one, the first type of writing it. Okay, initial value and value. Okay, I is equal to the initial value and the end value. This one means that we will have I as -2 at the first iteration, and then increase by 1, -1, 0, 1, 2 at the end. So I will take all these 5 values, okay, and then display them one by one. Okay, this one means that the output will be first round -2, second round -1, third 0, and then 1, and then 2. It will end at 2 because the 2 is the end value. Okay, this one looks quite similar, but actually this one is the third type that we have. Second type we have. Second. Okay, so the second type we have, okay, we have not only the initial value and the end value, but we have a step size here. So the step size determine how fast we want to grow from the initial to the end. So since the step size is 0.5 means that the first round, the first iteration we execute this one, will display -2. Okay, since you have a 0.5 here means that this is a double, this is a real number. Okay, and then the next iteration, okay, increase by 0.5, you see -1.5, and then followed by -1.0, 0.5, 1.0, 1.5, and then lastly 0.2 or 2.0. Okay, so this will be the output for the for this one. Okay, maybe let me give you a demo of the last one. 1 minute, let me copy the code. Okay, I open a new file. Okay, copy my code here. Okay, so save. Let's say I save as learn4.m. Okay, so I save already, and then the name of this program is learn4. I run here. Okay, you see this will be the output. Okay, I start with -2. Okay, and then okay, because since 2 is still an integer, so just print 2. Okay, -2, and then 1.5 is a real number, so we print -1.500. Okay, and then followed by -1, -0.5 until 2. Okay, so where is my code? Okay, here. So the other one is a while loop. Okay, while loop is quite similar to for, but the main difference here is in the syntax. You see, you have the while, okay, with the condition, but the condition doesn't come with a mechanism to increase the value that you want to count in the loop. So you have to manually put the increment or decrement of the element you want to count in the statement, in the body. Okay, this is an example. Okay, let's say we start with I equal to 1. Okay, and then I have a while loop. We start with a while keyword, and then of course you have to end the while with the end here, just like the for or if you need to have an end here. Okay, so okay, this is the body of the while. Okay, this is what you do, and this is the condition. Okay, the condition to stop the while is I must be less than equal to 10. While this is still true, okay, while this is still true, you will repeat this part. You will repeat the body of the while. Okay, and then what you do in the body, you display the I. You display the number, okay, I, and then you increase the I by 1. You increase the I by 1, so this is what you will do. So here you see, we'll start with I equal to 1. At the beginning, 1 is less than or equal to 10. This is true. Okay, 1 is less than or equal to 10. This is true. So you display I. You display 1. Okay, this output, and then you increase the 1 to 2. Now I become 2 already. Okay, when I become 2, you check. Okay, you repeat the loop. 2 is less than or equal to 10. This is still true. You display the I. So you display 2. Then you increase the I by 1 again. I become 3 already. Okay, 3 you check. 3 is less than 10. Still true. Okay, still true. You display the I 3. Okay, and then you increase the I by 1, 4. Okay, you repeat doing so until I equal to 10. I equal to 10. When I equal to 10, okay, you will display 10. You display 10, and then 10 add 1 to 10, you get I equal to 11. When I is 11 less than or equal to 10, this is not true. This is false. This is false. When this is false, the body will not be executed, so your program ends here. Okay, similarly, you can have nested while loop as well. Okay, like the if. Okay, you can put a while loop in this while loop, or you can put a for loop in the other for loop as well. Okay, so this is what you have learned in other programming classes, right? um, so one more thing is it's the AND and OR operator. So you see, we can combine multiple conditions into one, okay, with the AND and OR operator. Okay, of course, I think you know, AND means that all the conditions must be true, okay, in order to be true. OR means that uh, at least one condition is true, means that the whole condition is true. Okay, you must be all false to be false. Okay, so we, this is when we have, okay, all these are when we have multiple conditions. So you look at this example, I equal to 1, j equal to 10. Okay, this is definition. Okay, then while, okay, this is the condition. We have two conditions here. Okay, the first condition is I is less than or equal to 10. The second condition is j is greater or equal to 5. Okay, and we have AND operator here. AND. So AND means that we must make sure that both are true. Then only this part, the body, will execute. Only both are true, then the body will execute. So you see at the beginning, let me erase the thing first. Okay. Okay, at the beginning, I is 1, j is 10. Both are true, right? Both are true. So you will get a true for the whole condition, because both are true, and this is n. So you display 1 plus 10, I plus j, 1 plus 10. So this is the output you will get. The output is 10. Oh, sorry, 11. 1 plus 10, 11. And then I will be increased by 1. I become 2. J will be decreased by 2. J become 8. Okay, when you have 2 and 8 here, this is 2, this is 8. This is still true. This is still true, right? 2 less than 10, 8 less than greater than 5. This is still true, right? So we will display 2 plus 8. 2 for I, 8 plus for j, you display 10. 2 plus 10, 2 plus 8. So, and then after that, j will increase by 1 again, become 3. Okay, this one becomes 6, decreased by 2. So after you have this change, you have 3 here, 6 here. This is still true. Okay, this is still true. So when this is still true, the body will execute. You get display I plus j, 3 plus 6, 9. And then, okay, now you decrease j by I by 1. Okay, increase I by 1 can become 4. J minus 2, okay, is 4. This is 4 as well. Both are 4. So when both are 4, you come back to here. Okay, you execute the while loop. You have I equal to 4, 4 less than or equal to 10. This is true. 4 greater than equal to 5. The j 4 equal to greater or equal to 5. This is false, right? False and true. The AND will give you a false. So the loop will not execute anymore. The while loop will terminate here. So this will be the only output you have. Okay. Now let's change the program to, okay, instead of using AND, we use a OR. Use the OR here. The OR here, okay, require us to check both conditions. When any one of them is true, it will continue to execute. Okay, let's look at here. So at the beginning, ij 110, okay, 110, okay, because both are true, right? True, true, right? You execute, you print out 11. Okay, this is totally the same like this one. Okay, because this is the only difference is the n here, sorry, n here and O here. So this one we print 11, 10, and 9, just like what we have here. Okay, after the 9, this one will become 4, right? this one will become 4 as well. Okay, both are 4. 4, 4. Okay, uh, this one, okay, is true. This is false. True here, false here. 4 greater or equal to 5 is false, right? False. Okay, so because this is OR, so this will continue to execute. Okay, because true or false is still false. It's still true. Okay, true or false is still true. So this one will continue to execute. So you get 4 plus 4. 4 plus 4, 8. You get 8 here, and then you will get 1 plus I plus 1. This one become 5. This one become 2. Okay, minus 2 become 2. Okay, then you get 2, sorry, 5. 5 here, 2 here, right? 5 and 2 will still make this condition true, this condition false, but eventually it is still true. Okay, it's still true. So you get 5 plus 2 here, 7. Okay, you will continue to execute this one. Okay, until you can continue to execute the loop, okay, the while loop, until this one, okay, become 11, okay, because you see that I equal to I plus 1, I will keep on increase by 1, right? I will become 11. When this is 11, okay, this one should be okay, negative 10. Okay, this one should be negative 10, because this one increase 10 times, this one decrease 10 times, negative 10. Okay, so when you have this 11 here and this is negative 10 here, okay, this is false. This is false as well. False or false is false. Then only it will not execute. So the last output will be printed out here is when this is 10, this is negative 9. Okay, should be should be not negative 8, should be 2. Okay, so let me run this in the Octave to verify. Okay, let me copy. Editor, I open a new file, copy. Okay, of course we can put some space here to make it look nicer, but it's not required, but always good to make it look nicer so that you can read easier. Control S to save. Save it as learn while .m. Okay, now I execute the program in the command window. Learn while. You see, yeah, the output is negative 11. Just like I mentioned just now, start from negative 11 until 2. Until 2. Okay, so this is the while loop. Okay, so we have a few exercises here. Okay, please try, and then we will discuss it when we meet. Okay, or you can raise your question when we meet. Okay, for discussion. Okay, next thing we want to discuss is function. Okay, we know there are two types of function. Okay, one is the function that refer to the computer function, okay, programming function. What I mean here is a block of code, okay, we call it as a function. So when we call in another program, we can just call this function, okay, to let it repeat, okay, the code we have here. Okay, so this is a function of program, but the one that we are going to discuss now is a math function. Okay, this one we will discuss later. This one we will discuss in the later slide. Okay, but in this here we are going to discuss a mathematical function. like this one, fx equal to 3x plus 2. This is a mathematical function, right? Okay, in Octave, we can write functions easily in this way. Okay, let me demo. Okay, let me demo. Let's say I want to write a function fs equal to 3x plus 2. This is the function we want. Okay, in Octave, we can just write f. Okay, 1 minute. Okay, f. Okay, as the name of the function. If you want to change to ghi, up to you, but I use f here. F equal to, okay, now I want to specify the variable I have in the function, so I use add s. Okay, this one add with the add in a bracket, I put s means that I tell you the variable I have in this function is s. So then how is the definition of the function? Let's go back. Fs equal to 3s plus 2. So I just type 3s plus 2. This is wrong. Why? Because I have to put the asterisk here, the multiplication symbol here. Okay, this means that 3 times s, okay, plus 2. If you use the 3s like this, you get error. Okay, so you need to have a asterisk here. 3 times s plus 2. So this is the function. So you see, after I enter, okay, this thing come out, means that the function has been defined as follow: 3 times s plus 2. So now I can just put f3, let's say, okay, to get 3 times 3 is 9, 9 plus 2 is 11, to get 11. Okay, if I put f2, okay, I get 3 times 2 is 6 plus 2 is 8. F0, oh, okay, it's 2. F negative 1 is negative 1. This is how to write functions. Okay, but if we have a multivariable function, like this. Okay, fs is equal to, okay, if s is a vector, and then we have s equal to s1 and s2, two variables here, two variable function. So we can define this multivariable function, okay, with s1 and s2 in this form, with 3s1 plus 2s2. So I define, okay, let's say I don't want to call it f anymore, I call it as g. Okay, g is the name of the function, and then the variable we have here is s. Okay, the variable we have is s. Then 3s1 plus 2s2, 3s1 plus 2s2. This is how we write in mathematics formula, but in Octave, okay, it's a bit different. First, we need to have a multiply. Okay, 3 times s1, 2 times s2. You see here, 3 times s1, 2 times s2. Okay, but also for the s1 and the 2 here, these are the subscript, right? We put them in the bracket. Okay, 3 times s1 plus 2 times s2. So this is the definition of the function. Okay, so let's say I want to find x equal to 3, 4. Means s1 is 3, s2 is 4. How to do it? I put the g. Okay, now we call g, not f. In the matrix, in the matrix form, vector form. Okay, 3 for s1, semicolon, 4 for s2. Okay, remember to close the bracket. Okay, this is what we get. Okay, so 3 times, see, 3, 4, 3 here, 9, 2, 4 here, 8, 3, 8, 9 plus 8 is 17. Okay, so this is the one. If I want another value, just change it. Okay, for example, s1 is 0, s2 is 2, I get 4. Okay, because 2 times 2 here is 4. This is 0. Okay, this is the interesting part. Okay, plotting, we can use Octave to plot graph or even contours. Okay, so to plot contours, okay, this is what we do. Firstly, we define the range of x and y. Okay, maybe let's start with this one. Let's say I want to plot a function f. Okay, and f is defined as follow: x squared plus y squared plus xy divided by 2. Okay, this is a contour that I want to plot. Okay, for s, okay, for s here, I define s, okay, in the range of negative 5 to 5. Okay, s in this range, and y is in this range, negative 3 to 3. Okay, uh, okay, so this is the range of x and y. So I have these two lines, okay, to define the range of x from negative 5 to 5 for x. Y, okay, the range is from negative 3 to 3 y. So after these two lines, okay, we need this line, okay, to create a mesh grid, means a grid, okay, a grid for x, y, okay, where the range is defined as follow, defined here, okay, and then with this one you have a grid of x and y, and s, y here represents the variable we are going to use to define the function. Now in the line 4, okay, we define the function. You see this is s squared plus y squared minus sy divided by 2. Okay, let me explain this one. The function, okay, from here, function fs, okay, sy should be fsy, okay, two variables s and y. Okay, we call this, instead of calling this as fsy, I just call it as z. Okay, I just call it as z. So z is equal to s squared. This is s squared, s times s. Okay, but instead of just s times s, I need a dot here, because refer to the previous slide, remember or not, this asterisk symbol in Octave means matrix multiplication. We are not doing matrix multiplication, but we want the each s in the range multiply with the s at that position, I mean the same s. Okay, so we are doing the element wise multiplication. Okay, negative 5 times negative 5, negative 4 times negative 4, and so on, not doing the matrix multiplication. So this is the reason we need a dot here. We need a dot here because of this. Okay, and x squared plus y squared, same, we need a dot here because of the element wise operation, not the matrix multiplication of x times y times y. Okay, and then minus, this is 1 over 2, okay, divided by 2 times x times y. Again, you see this one, because x and y are matrix, okay, we need a dot here to show that this is not matrix multiplication but the element wise multiplication. Okay, so we have this function defined as follow. Then we plot the contour. We plot the contour using a contour keywords, and the contour keywords need three elements, three variables, s and y. The variables we have sy and the z, which will be the contour line. Okay, the value from the function which will be represented as the contour line. Okay, in the function. Okay, in the contour plot. I mean, so maybe let me show you the 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 program. Where is it? Okay, here is it. I have copied to the Octave already. So I run the program. The name of the program is plot1m. So I run the plot1, enter. You see, this is the contour we have. Okay, the lines, okay, this is the x, this is the x, this is the y, okay, and then the contour lines represent the value, okay, of z. Okay, the yellow one means the highest value here, and the blue one, or deep blue one, okay, or purple, okay, means the lowest value. Okay, how I know this? Okay, actually I can add one command. I plot again. With one more command here, editor. Okay, I add one more command here. I call it as a color bar. The command is color bar. Okay, with the bracket. Okay, I run again. You see, now this version comes with the color bar here. The color bar tells us that, okay, the color bar tells us that yellow is the value, okay, represent about 40, okay, close to 40, and then the deep blue color represent a value close to 0, 10, 5, and something close to 0 here, okay. Okay, so you see, yellow means something close to 40, okay, and then you follow the color. You can see the deeper the color, the darker the color, I mean, the smaller the value. Okay, this is the so-called the color bar. Okay, so okay, maybe I just explain a bit more about the contour. Okay, there are a few more variants of contour. Okay, this one I just plot with 3 variables, x, y, and z. Another version of contour is the one with one more parameter, a number. Okay, let's say I put 20 here. Okay, 20, I plot. Okay, same thing, but just I add a 20 at the back. You see, this is what I get. Can you find the difference? Yes, we have more lines here. We have more lines. 20 means that we have 20 levels of different value. Okay, compared to the previous one, we have less lines, means we use the less level of value. Okay, we show, not use, we show more less level of values. Now we have 20 levels of value here. Okay, so this is different. Of course, if you want, you can use a smaller number. Let's say I use a small number, just 5, okay, or 3, to let you see the difference. Oh wait, yeah, only 3 lines, right? So you see the difference of the n. Okay, the other version of contour is contour F. Okay, with the F here. Okay, with the F here. Okay, I just let you see. You can find the difference easily. Okay, you see the difference? Instead of using the color lines, we fill the contour with colors. We fill the contour with colors. So you see, still the yellow one means highest number. Okay, the deep blue is the dark blue is the lowest. Okay, so this is the the contour F. Okay, of course we can add number to the contour F as well. Let's say I use a 20. I think you can see the difference easy, right? So this is the contour F. Okay, besides the contour F, we have some other functions to plot graphs. For example, let's say we want to plot a 3D graph. Okay, not a contour, but 3D graph. Plot 3. Okay, so plot 3 is a function to plot 3D graph. Okay, you see, this is it. Okay, so you have this is a 3D plot. Okay, so you have this this tool here. You can see you have this tool here. Okay, for you to move. Okay, to view from different angle. Okay, you can see from different angle. Okay, so this is the first one, but the other one more, which is more popular, is the mesh. Mesh. Wait. Oh, okay. Mesh doesn't come with this number. Okay. Wait. Okay. See, mesh. Okay. Is the 3D version of plotting. Okay, you can see, you can move around and see how the function change. Okay, so so this is the different ways of plotting. um, okay, yes, I have described everything here. um, okay, so okay, just to make sure that you understand about the contour. Okay, when you have contour, okay, you can see like what we have just now. Maybe I show again. Your and contour. Okay, you see the circles. Okay, the center of the circles. Okay, normally center of circles means where is it? Means the maximum or minimum. Okay, the center of circles means maximum minimum. With the increasing of the circles, okay, you can see easily where is the center of the minimum point or maximum point. Okay, so this is the contour. This is compared to the 3D plot. This is a 3D plot. This is comparison, the contour. Okay, so whether this is a maximum or minimum, you have to refer to the color bar. Okay, when this is darkest, you see darkest mean minimum, right? So this is minimum. If you find this is yellow, that means yellow is a maximum, means this is a maximum point. Okay, so this is one, and then okay, yeah, this is a different plotting result. Okay, yes, one more thing is about color maps. You can change the, okay, if you do not like this one, yellow means highest, uh, and then the blue means lowest, minimum. You can change the color maps, okay, using the function color map with the name. You have a few, in fact many color maps here. Okay, you can change to anyone, depends on your preference. I just demo to you one example. Okay, close this one first. I plot again. With the color map function, what kind of map you want? Let's say I want a so-called summer. I run. Yeah, this is so-called the summer color map. Yellow is still the highest, green is the smallest. Okay, or I change to something like or maybe you prefer rainbow. Then you change to rainbow. Is it rainbow? I saw rainbow just now, right? Where's yeah, rainbow. Okay, actually I have also, okay, rainbow. Let's see. Actually I also have no idea what. Okay, yeah, sort of rainbow. Now, okay, red become the smallest value, and blue become the, or purple become the highest. Okay, so this is a plotting. Oh, yeah, one more thing. Okay, uh, just in case, we want to plot some more information in the contour or any graph we have. Okay, we can do this. Okay, first we must have a hold on. Okay, keyword. The hold on keywords means that we will keep the current uh, contour or whatever we have. Okay, we will continue to do plotting from there. Maybe, okay, I just show you. Where is it? Okay, I plot first. Is it? Yeah, it's a contour. Okay, plot plot first. Okay, now if I do anything, if I do any other plotting now, it will delete the graph we have. It will delete the graph we have. So in order to continue to plot on this contour, we need to issue hold on. Okay, hold on first, and then okay, we can continue to do the plotting there. Okay, now let's say we want to plot the line. Okay, because it's normal when, let's say, we already have a contour, we want to say, let's say we want to start the search. We want to show that we start the search from this point, and then we go somewhere, and then we eventually reach the minimizer. Okay, let's say we want to plot a few lines here to show that we start from here and then come to here. Okay, so we can continue to write these two lines. Okay, the line X and line Y. Okay, this is the first coordinate we plot. We start -2, -3. The second one, -1.5 and -2. Okay, and then the third one, 4. Okay, so we have these two lines. Let me copy. Okay, maybe I just put these two lines here. Okay, line X and line Y. Okay, I have these two lines. Okay, you see the contour is still the same because we just add two variable only. We haven't started the plotting. Now we plot do the plotting. Okay, with this one. This one means that, okay, we plot the line X and line Y as coordinate. Okay, first set of coordinate, second set of coordinate, third and fourth. 4 points. We have 4 points. 4 points mean 3 lines, and with the blue color, you see, this is what we have. First point, second point, third point, fourth point. So we have 4 points here. Four set of number. First, second, third, fourth. Okay, the last one is a 0, 0, right? So 0, 0 here. So this is the line we plot. Okay, we can change the line. Okay, for example, we can change the width of the line to 3. Then it become wider, right? So this is the plotting. Okay, of course we can put everything. Okay, we can put all these things, okay, all these lines into the same program. I mean, we can add these lines at the bottom here, okay, to make it a complete program to do the plotting. The last part is about output and also the user-defined function. Okay, so to define a function, okay, a program function, just like what I mentioned in the earlier video, you want our program, okay, to execute a block of program repeatedly. You can define this program as a function, right? So you can call this function, okay, numerous times from other program. Okay, so this is so-called a function. So Octave, we can create function like this, but normally to create function like this, we create another file. What I mean is, for a function, we create a file, okay, with the name of the file. Okay, with the name of the file is the name of the function. Okay, this is the name of the function. If you call it as name, that means the name of the function is name. Okay, and the output of the function is given here, and the input of the function is written in a bracket after the name of the function. Okay, and you start the function with keyword function and end the file or the function with the end function. So, and then you will add all the code you need, the block of codes you need in this, okay, in before the end function and after the function keywords. Okay, so let's look at this example. Okay, this example shows us a function called findDiff. Okay, a findDiff. You will need to save this file. Okay, this is a file. Okay, in a file called findDiff. okay, find diff 2, okay, find diff 2 dot m. Okay, you have to save the file as finddiff2.m, okay, because the name is given here, and then the variable, sorry, the function, okay, has one input only. The input is a matrix called A. The input is a matrix called A, and then with the A here, you can do all this processing. Okay, this is a code you have. Okay, this part is a code you have for your function. You see what you do is you find the matrix multiplication of A, you call it a B. You find the determinant of A, you find the determinant of B, okay, which is P and Q respectively, and you find the difference between the Q and P. Okay, with the difference Q minus P, the difference, okay, is the output of this function. Means what is a Q minus P here? It will be the output of this function. Okay, so for example, you find, okay, if you run this function like this, find diff 2 1 2 3 4, means you find you input a matrix 1 2 3 4. This will be the A, and then the A, okay, we input here, and then you find the determinant of A, you find the determinant of the matrix multiplication of B, of A, okay, and then you find the difference. The difference will become the output. Okay, you get the output here. So this is the user defined function. Okay, the last thing is to save and import data. Okay, to save a matrix, let's say you already have a matrix. Okay, you want to save a matrix. Okay, I mean the variable we have. For example, just now we have created a few matrix, right? Here, where is it already? So if you have created some matrix, you can save matrix. So, okay, let's say I create again k equal to 1 2 3 4. Okay, so after we create k, I can save the value of k. Of course, if k is only a small matrix, it's not worth to save maybe. But when you have a large data set, okay, maybe you want to save it, right? So you can save, okay, and this is the name, okay, of the file you save, and this is a variable you save. Okay, you have a ASCII parameter here to save the data you have in a form that we can read easily. Okay, what I mean is you can do this. You see, start with a save keyword, save. Okay, maybe I call it as a my file dot out. Okay, you can use other one if you would like. Okay, and that k is a variable we want to save. Okay, and then minus ASCII keyword. Okay, we save already. So in my file later, okay, you can see if I want, okay, I can use a okay, you can see I can find this file, right? Okay, yeah, I can find the my file.out. Okay, yeah, you see, this is the k I save 1 2 3 4. Okay, it's saved in the scientific format. Okay, so this one means that 1 times 10 power 0, 2 3 times 10 power 0, and so on. Okay, so this is to save the variable, and to load you can use the import data keywords function. I mean to load back the k, okay, to a variable called A. Okay, to save a graph, okay, let's say just now we have plot a graph, right? We can save the graph as well. Okay, using a print keywords, we can print the file. I think I've closed the file already. Before we delete the file, let me run again my program. Okay, so that you have to, if you want to save a graph or any plotting, okay, you need to make sure that it is still the plotting is still open. Okay, then only you can save. So here, let's say this is the one that I want to save. I run again. What's the name already? Plot 1. Okay, so this is the graph I want to save. Okay, while this one is still opening. Okay, I run print, okay, minus dsvg, okay, and then flow by the name of the file you want to save. Okay, let's say I want to save it as a plot1.svg. Here I save it as a svg format. Save. Okay, so I get a warning, but don't worry, I have saved the file. You see, I have saved the file here. Okay, this is in svg format. Okay, okay, yeah, if you find that saving in JPEG form is more popular, you can just change this one. Okay, where is it, to JPG, and of course this one to, okay, dash DJPG. Okay, if you have the library, okay, to install in your computer, you should be able to save it. Let me try DJPG, plot JPG. Okay, so you see plot1.jpg is here already. So you can see this is a plot I have just now. I save it in a file. Okay, I think yeah, that's all, and I have a few exercises here. Please try. We can discuss if you have any question in the next lecture. Okay, just 3 questions. Okay, thank you. Let's look at the exercise for the line search method. Okay, so we have a function here. Okay, so we want to find, okay, when sk, okay, we are at this 2 1, s1 is 2, s2 is 1. Okay, using the steepest descent method, determine the sk plus 1, the next point we stop. Okay, if the step length is given as 0.3. Okay, so maybe let's start with the function. Let me copy. So this is the function. So firstly, okay, because we want to find the standard using a steeper descent method, right, to determine the next point. Okay, so the first thing is we need to find the gradient. Okay, because steeper descent method we need gradient, so the gradient of this one is, okay, the gradient, okay, 4s1 cube plus, okay, 4s2, okay, and then this is 0 because there is no s1 here. Derive over s2, you have, this is 0, this is s1 plus, okay, this is 2 1 plus s2. Okay, so this is the gradient of the function. Okay, so okay, even though it is not required for the gradient, I mean for this part, I will also find the Hessian, because I know, okay, for the second part is later. Okay, the Newton method we need Hessian, so I will find the Hessian. Now the Hessian is, okay, so this is for, wait, yeah, correct. So for s1 I have 12 s1 square, and then, okay, 0 here. Okay, s2 I have 1, Okay, because of this one, derive for this one, I have 1, this one 1 as well. This one we derive for as 2, you have 2. This is the Hessian. Okay, so you see, to find the next point, okay, sk plus 1, okay, using the statistical descent method, from starting from this point, 2, 1, okay, sk plus 1, okay, is equal to sk, okay, sk plus alpha pk. Okay, now we know already sk is 2, 1, 2, 1, and then alpha is given 0.3. Okay, pk, what's pk? Pk is just a negative, okay, of the gradient. Okay, the negative of the gradient. So the negative, this is the gradient. Okay, the negative of the gradient is the negative of this one. Okay, look at this one. Okay, maybe I write here. Okay, the gradient, okay, you see when s2, s1 is 2, s2 is 1, given here. Okay, so the gradient, okay, substitute 1 here, sorry, 2 here, you have how many? This is 24 plus sorry 32 plus 1, right? And then this is equal to this just this is equal to 33, and this will have 8. Okay, so this is the gradient. So the negative of the gradient, the pk, negative of the gradient is negative 33, negative, negative. Then you have, okay, you do the computation, you will get negative 7.9 and negative 1.4. Okay, so this is the next point. You stop using the steepest descent method. Okay, so okay, let me, okay, let's go back, okay, and look at the, we done this one. Okay, the part 2, when sk is this point also, using Newton method, determine if the Hessian is positive definite. Okay, find next point sk plus 1 with alpha equal to 0.3 if it is positive definite. Okay, so maybe I start from here, I copy. Okay, so okay, firstly, let's settle this part first. Okay, determine if the Hessian is positive definite or not. Okay, this is a Hessian, this is a Hessian. So the Hessian, you see, when at s2 equal to 1, s1 equal to 2, okay, so we find the Hessian is equal to, substitute 2 here, you have 48, 1, 1, 2. Okay, this is a positive definite matrix. Why? Because first, 48 is greater than 1, than 0, sorry. And second, determinant of 48, 1, 1, 2 is equal to 96 minus 1, which is 95. Okay, that is, you see 96 here, minus 1, 95, greater than 0 also. So positive definite. Okay, so now let's continue. Okay, now we want to find the next point. Okay, for Newton method, the next point sk plus 1 is equal to sk, similarly is equal to the alpha plus the pk. Okay, direction, the step length, add with the current point, you get the next point. But the issue here is the pk is not that simple. The pk is negative of the inverse of the Hessian. The inverse of the Hessian product with the gradient. Okay, so this is the the calculation for the next point using the Newton method. This is what? This is the 2, 1. Alpha is 0.3. Okay, and then the negative. This is the Hessian. Okay, this is the Hessian. So we want to find the negative. Okay, of course, to find the negative is very easy. Just add the negative here. Right? It's very simple. But to find the inverse, okay, you need to do a calculation. You need to find the determinant first, and then you find the inverse of it. Right? So I've done it already. This is equal to how many? Negative 0.0215, and then this is 0.0105, 0.0105, and also negative 0.5053. Okay, this is the inverse of the Hessian. And the gradient, we have the gradient already just now, right? The gradient is 33 and 8. We get the gradient from the first part, this one. Where is it? This one. Okay, so here, from here. So you complete the calculation, you find this is equal to how many? 1.817 and 0.108. Okay, so this is the next point that your search stop using the Newton method.